All right, let's jump right in. We've got a story for you today that connects two places you'd probably never ever put in the same sentence: the cornfields of Iowa and the deep waters of the Gulf of Mexico. It's a wild story about a huge problem and, believe it or not, an even bigger, more surprising solution.
So, this is the central question, right? How on earth can a completely landlocked state, I mean, we're talking hundreds of miles from the ocean, be the single most critical place to solve a massive ocean crisis? It sounds kind of paradoxical, doesn't it? Well, that's exactly the puzzle we're going to unpack. Okay, so to even start to get our heads around this, we have to look at this connection. The sources we're digging into make this really bold claim. If you want to fix the Gulf of Mexico's biggest environmental disaster, Iowa is, well, it's non-negotiable.
And this quote, man, this just says it all, doesn't it? If you don't fix Iowa, you won't fix the Gulf. That is such a powerful statement. It basically puts Iowa smack dab in the center of this whole ecological and economic challenge. It's not just a piece of the puzzle, it's the absolute cornerstone. So why? To get why Iowa is so critical, we've got to start with a problem. You know, the why Iowa part of the equation. What is it about this one state that makes it the single largest source of the pollution that's creating this dead zone in the Gulf? It all kind of starts with this number right here, 85%. An absolutely staggering 85% of Iowa's land is used for agriculture. Now, to give you some perspective, the average for the whole U.S. is around 40%. So Iowa is more than double the national average. That massive agricultural footprint, well, it sets the stage for an equally massive environmental impact. And listen, it's not just any kind of farming. We're talking about a super high-intensity model. Think about this combination of things. You've got these intense corn and soy rotations year after year. You've got heavy use of synthetic fertilizers. You have a huge footprint from what are called CAFOs, confined animal feeding operations. And on top of all that, you have very few natural buffer zones like wetlands or forests to soak anything up. It's kind of the perfect storm for generating a massive, and I mean massive, load of nitrogen and phosphorus runoff. Now, this is super interesting. This didn't just happen by accident. Iowa's landscape has been, for all intents and purposes, engineered. It's like a giant plumbing system. It's crisscrossed with this subsurface tile drainage, and most of the natural wetlands have been removed. The whole thing is designed to do one job really well: flush water off the fields as fast as possible. But here's the catch. That water takes all those excess nutrients right along with it for the ride. And that journey, from a farm field to the sea, it's a straight shot. So fertilizers go on the fields in Iowa. That super efficient engineered landscape flushes the extra nutrients away into the Mississippi River. And then that nutrient-packed water flows all the way down to the Gulf of Mexico. Once it gets there, it's like dumping super fertilizer into the ocean. It causes these enormous algal blooms. But when all that algae dies and starts to decompose, it literally sucks all the oxygen out of the water, creating what we call a dead zone, or hypoxia, where basically nothing can survive. And as you can see here, the fallout from this isn't just ecological. We're talking about billions, with a B, billions of dollars in economic damage. The fishing and shrimping industries, I mean, these are the lifeblood of so many communities down on the Gulf Coast. They collapse. Tourism takes a huge hit. The entire coastal economy suffers. This is the real-world price tag for that nutrient flush happening hundreds and hundreds of miles upstream. But and this is where the story gets really interesting and takes a complete 180. It turns out the very things that make Iowa the biggest source of the problem also make it the perfect place to launch the solution. It's basically ground zero for a regenerative revolution. Okay, just look at this comparison. On the left, you have the big problems in Iowa. On the right, you have the benefits of one specific technology called biochar. Now, biochar is basically a special kind of charcoal made from agricultural waste. And check this out. For nutrient runoff, biochar can lock up to 60% of the nitrogen in place. For degraded soil, it massively increases how much water the soil can hold. That in turn means farmers need less expensive fertilizer. And the kicker? It permanently sequesters carbon right there in the ground. It's like a perfect point-for-point counter-solution. And you know what? Biochar is just the tip of the iceberg. There is a whole suite of these advanced regenerative solutions just ready to go in Iowa. We're talking about everything from simple things like cover crops and restoring wetland buffers, to super high-tech stuff like robotics for precision fertilizing, and even using blockchain to track and verify that these sustainable practices are actually being used. Iowa could become this massive real-world laboratory for the future of farming.
So, what this all leads to is a complete rethinking of the idea of waste. Iowa's huge streams of agricultural waste, food waste, even plastic waste, they're not a liability anymore. In this new circular economy model, they become incredibly valuable resources. Ag waste gets turned into biochar. Food waste becomes compost and soil amendments. It's all about turning what we used to see as a problem into a valuable product.
Okay, so we've got the problem, and we've got a whole toolbox of solutions. But how does fixing farming in one state become the key to unlocking a solution for the whole country? The answer is all about leverage. Iowa acts as this incredibly powerful strategic lever.
And the sources we looked at show that Iowa gives us leverage in 3 really critical areas, which you can see right here: political, economic, and institutional. It has this unique political influence, huge economic potential, and all the right institutions are already there to make change happen fast. Let's break them down. Okay, the political angle. Think of Iowa as the swing state for this whole Mississippi River restoration effort. If you can prove that these solutions work here at the absolute epicenter of the problem, you can build an incredibly powerful political coalition. You start to reduce that economic damage down in the Gulf, which gets the coastal governors on your side, and that support is what unlocks crucial backing from the USDA and big federal funding. It creates a clear path for bipartisan support. And then there's the economic lever. This is huge. This isn't just about spending money to fix a problem. Solving this creates an entirely new multi-billion-dollar market for all these regenerative technologies and practices. It's a massive economic opportunity just sitting there, waiting to be unlocked.
And finally, you've got the institutional lever. This is so important. The key players in Iowa, they're already looking for these solutions. You've got Iowa State University, which does world-class research on biochar and water science. You've got the state's Department of Agriculture. All these groups are already aligned and ready to jump on board. And that means these solutions can be rolled out incredibly fast.
Okay, so let's bring this all home and finally solve that paradox we started with. How can the biggest problem also be the biggest solution? This right here is the single most important idea to take away from all of this. Iowa is both the problem and the solution. Its unique position as the #1 source of the pollution is precisely what makes it the non-negotiable #1 place to start fixing it.
When you boil it all down, it comes to this. No other state in the country offers this unique combination. There is no bigger agricultural testing ground to prove these solutions can work at a massive scale. And there is no other state that has more direct leverage over the health of the Gulf of Mexico. If you want to fix the sea, you've got to start with the soil. And that really leaves us with one last big question to think about. This whole model, tackling a huge problem by zeroing in on its most concentrated source, it could be a blueprint for so many other things. So what other global challenges, from plastic pollution to public health crises, could we solve by looking for their Iowa? That one place where the problem is so intense, it actually becomes the perfect proving ground for the solution.